Just for introductions, my name is Jared Landsman, and I'm gonna just chat to you guys a little bit today about my experience in India this past summer. And I was there doing work with something called the Center for Building Energy Research and Development, which is also known as CBERD. So just a little bit about what is CBERD. It's a organization that's sort of promoting energy efficiency in both India and the United States. And it's a collaborative research initiative between the two countries with a focus on commercial and multifamily residential buildings. It's a 5-year-long project which started in 2012, and so we're right in the thick of it right now. And there's a bunch of research and development partners across both countries. Within the United States, they're being led by Lawrence Berkeley National Labs, and then in India, it's being led by CEPT University. So just a little bit more about what my specific role was. I was working on one of 6 tasks within this organization, which was called Task 6, or Climate Responsive Buildings. And just to go a little bit further into what that means, the objective of this task was to better understand the performance of well-designed, passively designed buildings. For those who don't know what passive design is, this is strategies such as natural ventilation and nighttime ventilation and increased air movement. So within this area of climate responsive buildings, my specific task when I was in India over the summer was looking at what you see in red there at the bottom, which was the physical performance of buildings in India, in addition to a laboratory study that focused on thermal comfort. So I'm going to give some updates first on the work that I did regarding building monitoring in India, and then I'll go a little bit into the laboratory study that I conducted.
So you were in the red part of India, the hot and dry. You were working there.
For the most part, yes. So I was in 2 zones of India. For my first portion, I was in a city called, I guess it was more of a village called Auroville, which is in southern India. It's close to Pondicherry. Okay. And then for the remainder of the time, for the most part, I was in that hot and dry region in Ahmedabad.
In Ahmedabad, okay.
So just to go a little bit into this idea of monitoring, the main objective was to collect data from buildings all over India in different climate zones to see how these passive design strategies are performing with regards to comfort of people inside the buildings. Listed up here is just a few of the strategies that we were analyzing within these buildings across India. For example, there's different strategies for daylighting, different strategies for natural ventilation, like courtyards and stack ventilation in solar chimneys. And in addition, there were a few buildings that were using some special kinds of insulation or materials that were high in thermal mass. One of the most innovative strategies we saw that's really unique to India was this idea of walls that had the sort of cavity walls that were used for to increase the air movement and for higher insulation properties for the buildings in India. And that's something that we hadn't really seen in the United States before.
What does that mean, cavity walls?
So there's it's a very basic concept, but in essence, it's walls that had either air cavities or air spaces inside them that allowed air sometimes to flow through or sometimes air to just get caught in that cavity, which helps increase the insulative property of the wall. It's a very basic, really low technology strategy for cooling inside the buildings, but it's fairly unique to the buildings we saw in India.
And they were mostly made out of cement, right?
A lot of them, yes, mostly either cement or some form of concrete. So specifically while I was there, there's been data that was collected from these buildings for the past year or so. So when I was there, I consulted with the owners of these buildings and the people that were collecting the actual data to make sure everything was sort of going according to the right process, according to plan. So we were specifically looking at data being collected on air temperature and humidity and the globe and surface temperatures within these spaces, using some of the instrumentation that you see on the screen right now. And currently, while I was there and still continuing, I'm looking at conducting some analysis, looking at the performance of these different strategies and how they are performing specifically with regard to comfort of the people inside the buildings. In addition, one specific area that I mentioned that we were looking at is this sort of like a global village called Auroville. This area is unique in the sense that it's both hot and humid, and the architecture there is fairly well known for its passive design strategies, some of which are listed on the screen. So we've been collecting data there for the past year, and while I was there, I consulted with all of the building owners. I started obtaining a lot of the data that we were looking at, and started actually doing some of the analysis to see how these buildings were performing. So just as an example, on the screen right now is a graph of the indoor and outdoor air temperature of one of the buildings in this village of Auroville. That's specifically using a strategy of nighttime ventilation. And as you can see from the red line, which is the indoor temperature, there's a significantly thinner deadband of temperatures for inside than there is outside, and this is mainly due to this night ventilation cooling strategy.
Like Jared, it seems like the highs and lows are more contained indoor than outdoor, like more of a kind of a straight line. You can't expect too many highs or too many lows inside versus outside. Is that what we're saying?
Right, yeah. So because of the building is using this scheme of night ventilation, it's able to minimize the indoor air temperature, or at least minimize the range of indoor air temperature throughout the year. So even though it clearly is that the outdoor air temperature gets a lot warmer in the summertime, the indoor air temperature stays fairly constant during that time. So this was seen as a pretty big success for that kind of strategy used in a hot and humid climate. So in addition to the buildings in Auroville, we were also able to visit and analyze some of the other buildings across different climate zones. So I actually got to visit a few different cities in India, including Mumbai and Delhi, looking at some buildings there. All of these buildings were using a technique. They're all considered mixed mode, which means they use some combination of passive cooling strategies in addition to mechanical cooling, so some form of air conditioning. And these, for the most part, were larger commercial buildings. And we had a really unique opportunity to analyze these buildings with respect to a new comfort model that was just developed at CEPT University, which they called the IMAC, the India Model for Adaptive Comfort. And as you can see in the chart below, the black dotted line represents the acceptability limits of this new model for comfort within India. And the dots that you can see represent a few specific days in one of these buildings. And for I think all but one of these days, all the dots fall within this India Model for Adaptive Comfort, which is really significant because although it is so hot in India, especially in this specific region, it seems as though people in India are more tolerant of these hot conditions, and they fall within this specific model of the acceptability limits. So it's significant in the sense that we have to start looking at how people who have different expectations for different climates and different expectations for different temperatures can actually withstand different temperature limits.
So you're looking just to make them more comfortable with respect to like humidity and temperature, not getting too hot, not getting too cold. That's basically what you're looking at.
So it's a combination of trying to make sure they're more comfortable in addition to seeing how acceptable they are of different limits or different conditions. So it's possible that someone in India might be very much more tolerant of a condition than someone in the United States to that same condition, just because they have different expectations.
I see. And you were going over there to improve the design, right?
Yeah, so we were specifically looking at existing designs in buildings that are believed to be performing well. So as opposed to creating new designs, we want to see how these existing designs are performing and what's performing well and what's not performing well, and then trying to assess why these strategies may or may not be performing well.
I see. Okay.
And they're significant because they are all strategies that we were looking at are low energy strategies. So if the low energy strategies can be successful, that is a really good thing for designers to know moving forward in the design world.
Okay.
So switching gears a little bit, we were also I was also responsible for coordinating a study that was done in the new thermally controlled chamber that was just built at CEPT University. So I know that term is not so common, so just to sort of explain what that means, there's a room that was just recently constructed and the people who work at the research center have the ability to manipulate the temperature and humidity of the room very specifically and to a very minute degree, so that you can test different conditions in the chamber and see how people respond to different conditions in that chamber. So our specific objective was to determine what the impact of air movement is on thermal comfort in a hot and humid environment. And for this specific study, we wanted to see how people would respond to these conditions if given personal control of a fan. So the subjects of the study were sat down at 2 different workstations within this chamber and given the ability to use a pedestal fan that was right in front of their desk, which is seen on the screen right there. And we tested these in 8 different thermal conditions. So before we were actually able to initiate the study, we developed a pretty intensive work plan just to coordinate when subjects would be able to enter the chamber, which different conditions we wanted to test on which days. And then once again, also before we were able to actually allow subjects into the space, we had to calibrate all of the equipment. We wanted to specifically see what the different air velocity and fan powers were for each of the settings with these pedestal fans to determine how their chosen air velocity impacted their specific thermal comfort. And then we had 20 different subjects do the study with us. We made sure that all 20 subjects were acclimated to the hot Indian climate, which in Ahmedabad that they were currently residing in. We also made sure they all wore sort of a typical Indian summer work attire. And I was responsible for actually administering the experiments in the space and sort of interacting with all of the human subjects. So,
Jared, how did you actually get these subjects? I mean, did you go out and ask them? I mean, how did you do that?
Yeah, so the research center that I was working for was sort of responsible for finding the subjects. They were all roughly within like a 10-year the span of ages of people who coordinate or participated were all in like 10 to 15 years of each other. Most were either employees or students of the university. And so yeah, that I wasn't so much responsible for getting them there, but once they were chosen, I was responsible for sort of interacting with them and making sure they knew what they were doing.
Okay.
So when I say they participated in the study, what that means is that they sat in the chamber for about an hour and a half at a time in 8 different scenarios, each with the room in a different condition, at some different variation of a very high temperature and high humidity. And about every 15 minutes or so, they answered a survey on the computer that was sitting in front of them, asking how they felt about their thermal environment, if they were comfortable, if they found the temperature to be acceptable, or if they wanted to be warmer or cooler, or how satisfied they were with their air velocity, or if they wanted to change that or increase or decrease their air velocity. So once that was all complete, the next step was to actually analyze our results, analyze the data, and see what these people were saying and how they were responding to these different conditions. So the first thing we looked at was their chosen air velocities. So as you can see here, these are the 8 different conditions which we tested at, that ranging from 26 degrees Celsius and 60% relative humidity to 32 degrees Celsius and 80% relative humidity. The biggest takeaway that we saw from this was just that the subjects had a really wide range of airspeeds that they preferred. If you look at sort of the middle 4 conditions, their airspeed preference ranged from 0 meters per second to about 1.5 meters per second. So the biggest takeaway here is that it's really important to give people individual control of their airspeed to satisfy their comfort. The next thing we wanted to see was to what extent the air movement actually compensated for the hot and humid conditions for the individual's comfort and temperature acceptability. So first we looked at the parameter of thermal acceptability, and as you can see here, there's for each of the conditions, up to 32 degrees Celsius and 60% relative humidity, at least 90% of the subjects found that condition acceptable. This is really significant because in previous studies that were done in a similar nature in other parts of the world, we've really never seen people reach this level of acceptability higher than about 30 degrees Celsius and 60% humidity. So this jump up to 32 degrees Celsius might mean that people in India are just more acceptable of their thermal environment at higher temperatures.
Is it, you're comparing them to people in other hot climates like Africa and things like that, or to people in the U.S.?
Yeah, so the studies that we're currently comparing it to have been done in the United States and Denmark and China. So India is probably the hottest climate that these tests have been done in, which might just simply indicate that the people who are acclimated to the Indian climate are the most, have the highest expectation for these high temperatures.
Okay.
In addition, we looked at the parameter of thermal sensation, which subjects were able to choose between feeling very cold all the way to very hot, with neutral being in the center. And once again, the results here were fairly significant for us because it showed that up to that same value of about 32 degrees Celsius and 60% relative humidity, almost all subjects felt in this neutral zone between slightly cool and slightly warm. And this is really something that was unprecedented before in tests that have been done in other countries. And finally, we looked at the parameter of temperature preference. So although all these subjects said they were acceptable or felt neutral, if you look at their actual temperature preference, at least 25% of the subjects still preferred to feel cooler, 28 degrees Celsius and higher. So this sort of tells us that as designers or as practitioners, the question is, what do we want to really know? Do we want people to feel as though their area is acceptable or neutral, or do we want them to actually feel as though they don't want it to be warmer or cooler? So this is sort of a question moving forward in the research that's going on, and that's still being looked at. So in terms of the current work and the next steps for the project, which are still going on, there's I mentioned there were studies that were done in other countries. So there's more of a desire to see how this data really compares with these other studies. As you can see up on the screen, this is data from the Indian study, in addition to 2 studies that were done in the United States in a similar nature. So looking at this parameter it's called standard effective temperature, which is on the x-axis, which is sort of a combined effect of the temperature and humidity and the air velocity. We can see from these sort of linear regression lines that the data from the Indian study is significantly below both lines for the US studies, which once again shows us what we would have expected to see, that the Indian subjects felt more close to the neutral area than, or stayed more close to the neutral area than the US subjects did for those studies. So this is work that's still currently going on, and there's going to be further investigated probably in the next few months. And that is kind of a summary of what my role was within the project when I was in India.